Today we will conduct this experiment for which is determining frictional force on a two different surface.
The objective of the experiment is to determine the coefficient of static friction of different surfaces.
Wooden block rubber covered at one side, 50 gram masses, 10 Newton spring scale, and tabletop.
For the first question, which is draw and label the free body diagram of the wooden block. For table 5.1, which is rubber surface towards the floor, only two force that acts to the wooden block, which is normal force and gravitational force, while the non-rubber surface towards the floor have three force, which is friction force, normal force and gravitational force. Here are the graph at static friction force versus normal force. This is the graph for rubber surface. And this is the graph for non-rubber surface. Use the gradient obtained from the graph to calculate the coefficient of static friction for each surface. Compare and discuss the coefficient of static friction obtained. So, the coefficient of rubber surface is higher than coefficient non-rubber surface. It is because non-rubber surface has friction while rubber surface is frictionless. This means the rubber surface wooden blocks need less force to move than the non-rubber surface. First, how can anti-lock brakes stop a car in a shorter distance than regular brakes? ABS pulse the brakes in this manner to keep static friction keep playing rather than the weaker force of kinetic friction stops the car more quickly than it would lock the wheels. Question number 2. From your experiment, which method has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? Rubber surfaces have the higher coefficient of static friction, which prove that the hypothesis is accepted. The coefficient of static friction can be determined by ratio of the maximum static friction force between the surface in contact before movement commences to the normal force. Question number 3. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. Once it begins, mass undergoes stop and go motion because it creates greater weight. With greater force downward, the mass cannot move smoothly due to the friction that acts between the surface to become greater.
This experiment is carried out to determine the coefficient of static friction of different surfaces. There are a few precaution steps that have been done in this experiment to make sure the value of all the trials are accurate. Before the observation of the readings, all the apparatus as in figure 5.2 are made sure clean, no damage, and be aware of the zero error on the spring scale. Each measurement of the static friction force was determined by being repeated for 3 times of pulling the spring. During the observation, the eyes of the observer need to be placed perpendicular to the measurement of the spring scale. The value of each trials will measure once the 50 gram masses is being placed on the wooden block and ready to be pulled. This experiment is succeeded.
Experiment is done to determine the coefficient of static friction of different surfaces. Force, vector, gravity, and velocity are also involved when conducting the experiment. This shows that the coefficient of friction is the most effective way to solve problems that involve the force of friction. Normal force is perpendicular to the contact surface of two objects, and from here, the coefficient of friction can be found. When the mass of a wooden block with a rubber surface increases, the static friction force increases. According to the results, the mass G of the wooden block with a rubber surface is 50 gram, where an average of 0.6 Newton is obtained. For 100 gram of mass, the average static friction force is 1.0 Newton. While the mass of the wooden block with a non-rubber surface is 50 gram, the average obtained is 0.2 Newton. Then 100 gram of mass gets the average static friction force of 0.4 Newton. With that, based on the collected data, the mass of a wooden block with a wooden surface M is 82.53 gram with an uncertainty of 0.01 gram.